Welcome to Spring LIB.
So in this problem, we are given with um, trimethyl gallium, which will react with arsenide gas, and which will produce a semiconductor named gallium arsenide. So in first part of this problem, we have to find out what will be the or what mass of gallium arsenide will be produced from 450 gram of trimethyl gallium and 300 gram of arsenide. So to solve this problem, first you have to write down a balanced equation for the reaction of trimethyl gallium with arsenide gas, which will be like this. So here is the reaction of trimethyl gallium with arsenide gas to produce gallium arsenide and methane gas. So first you'll have to balance this equation. So for balancing, we can see that we have one gallium on each side, we have one arsenic on each side, then we have three methyl group in this side, but we have okay, we can just count that three carbon in this side, but we have one carbon in this side, so that means we'll just place a 3 here. Now we have three carbon on each side, and now we have 3 times 3 9 plus 3 12 hydrogen, and 3 times 4 12 hydrogen. So now we have the equation balance. So this is the balanced equation for this reaction. So from here we can see that 1 mole of trimethyl gallium reacts with 1 mole of arsenide gas to produce 1 mole of gallium arsenide. Now we are given the mass of trimethyl gallium and mass of arsenide gas. So what we have to do is we have to find out the number of moles of this masses of trimethyl gallium and arsenide, and from there we can find how many moles of gallium arsenide will be formed from this, and from there we can find out the mass of gallium arsenide which will be formed. So first we'll find out the number of moles for gallium arsenide, which is CST3GA. So that will be the mass of gallium arsenide, that is trimethyl gallium. So it will be mass of trimethyl gallium, which is 450 gram, over the molar mass of trimethyl gallium. So let's find out the molar mass of trimethyl gallium. So the molar mass of trimethyl gallium will be, we have 3 carbon, that means 3 times 12.01, which is the molar mass of carbon, plus we have 3 times 3 9 hydrogen. So we'll have 9 times 1.008, and then we have 1 gallium, and gallium has a molar mass of 69.723. All of these are gram, so it will give us a value of 114.825 gram, and this is the mass of 1 mole of trimethyl gallium. That means 114.825 gram per mole is the molar mass of trimethyl gallium. So we put this under the mass of trimethyl gallium, 5 gram per mole, which will give us a value of 3.919 mole. So this is the number of mole of trimethyl gallium which is reacting. Now we'll find out the number of mole of arsenide gas. ASH3, which is reacting. So the Mass of arsine which is given is 300 gram, and the molar mass of arsine, if we calculate, the molar mass of arsenic is 74.922 plus 3 times the molar mass of hydrogen, since we have 3 hydrogen here, and it will give us 77.946 gram per mole. So just put this here, 77.946 gram per mole, and it will give us a value of 3.849 mole. So this is the number of mole of arsine gas which is reacting. So we have 3.849 mole arsine gas, and we have 3.919 mole trimethyl gallium. So from the balanced equation, we can see that 1 mole of trimethyl gallium will react with 1 mole of arsine gas. That means uh, 3.849 mole of arsine gas will react with 3.849 mole of trimethyl gallium. So the point here is, this is the arsine gas is our limiting reactant here, since it is um, lower in amount, and since we need the same number of mole of both the reactant, and since the number of mole of this reactant is lower in amount, that means it will be completely consumed, and the reactant which is completely consumed is the reactant which we call the limiting reactant. And that means the amount of gallium arsenide, the gallium arsenide which will be formed in this reaction will be based on this number of moles. So 3.849 mole of arsine gas will react with 3.849 mole of trimethyl gallium to give us 3.849 mole of gallium arsenide. So the number of moles of gallium arsenide which is being produced is 3.849 mole. From here we can find the mass of gallium arsenide which will be produced. So mass of gallium arsenide will be the number of moles of gallium arsenide, 3.849 mole, times the molar mass of gallium arsenide, which is 144.645 gram per mole, and it will give us a value of 556.712 gram gallium arsenide. So this is the mass of gallium arsenide which will be formed or produced in this reaction. So that is our answer to our question A. Now in our part B of this question, we have to find out um, which reactant is left over and how many moles of the reactant is left over. So from here we can see that we had 3.919 mole of trimethyl gallium, but in the reaction we are reacting only 3.849 mole of trimethyl gallium, and the arsine gas we had it 3.849 mole, and this is actually completely consumed. That means this is a limiting reactant, and this will be our excess reactant. So this is our excess reactant. So the excess amount or the reactant that will be remaining or left over is trimethyl gallium, and the amount that will remain is the amount of trimethyl gallium we had, 3.919 mole minus the amount of trimethyl gallium which is reacting, which is 3.849. So we had this much in the reaction mixture and we are reacting this much. So the amount which is left over will be the subtraction, and it is the value will be 0.07 mole. So this is the number of mole of trimethyl gallium which will be left over after the reaction is completed. And then in part C of this question, um, we have to find out what area in centimeter square in a thin film of 40 nanometer will the mass of gallium arsenide which is produced from part A will cover. So what we'll do, we have calculated the mass of gallium arsenide, and here we are given the density of gallium arsenide. So if we multiply the mass by the density, we will get the volume of gallium arsenide. And if we just divide the volume by um, the length of this thin film, we can find the area of thin film which will be covered by this mass of gallium arsenide. So first we'll find out the volume of gallium arsenide, which will be mass of gallium arsenide 556.712 gram times the density which is given as 5.32 gram per meter cube, and this will give us a value of 2961.7 meter cube. So this is the volume of gallium arsenide, and the area of the thin film which it can be covered is, so the length of the thin film is given as 40 nanometer, which is 40 times 10 to the power minus 9 meter. So the area which can be covered will be the volume of the volume of gallium arsenide, which is 2961.7 meter cube over the length of the thin film, which is 40 nanometer, or 40 times 10 to the power minus 9 meter. It will give us a value of 7.40 times 10 to the power 10 meter square. So we have to find the area of the thin film which can be covered in centimeter square. So if we just convert it to centimeter square, it will be 7.40 times 10 to the power 14 centimeter square. So this is the area of a thin film of 40 nanometer which can be covered by the gallium arsenide formed in this reaction.